Hey, welcome back to the channel. So in this final episode in this series, I want to talk about recycling your work. So that we did the series on part 1 and 2 of building the collar. This little doogie here, right? And this was great. It did a fantastic job. It did exactly what it was designed to do. You can see it's got a little bit of a taper to it. If you haven't watched the videos, I recommend you go back and watch parts 1 and 2. Look, it never fails. Whenever I start to record, some idiot starts a bloody sweeper or a mower or some machine up. Never fails. Anyway, that said, what we're going to do is we're going to make a bigger one of these because we've got a new reel, and the new reel has a bigger hole size than this. So what we're going to do is we're going to take you through how I recycled the work I did to make the collar. It's got to be wider, so it's got to be thicker this way. It's got to be bigger diameter. The inner diameter remains exactly the same, so it's got to be probably a bit thicker to support the collar. We'll have a look at that. So we'll get into it. Now, once again, this is completely at your own risk. I accept no responsibilities whatsoever. So if you can't follow along at your own risk, by all means, click this off and off you go. Otherwise, sit back and strap in and let's get into it. I'm recording yet again with this collar because I've got another reel that has yet a different diameter. Now, I don't want to make this whole thing for it, really, except that, you know what, who gives a? So I took a couple of measurements with my caliper. We got a new width. The new width is 65 millimeters. The new outer diameter is 57. So 52 was just a little bit too small and it was too thin to go through the thing. So it's now 65, same spokes. I'm going to up the thickness a little bit to 5 because it's a heavier reel. It needs to be a bit stronger. So we've now got this kind of arrangement here. As you can see, it's more robust, it's wider, it's still got that 1 millimeter taper. And we can print this out. And we've still got the same basic design. Now the trouble is that there's no grip point for this at 65, so I'm just going to make it too longer. I'm just going to go to 67 and redo that. Let's compile it. I've got a television going in the background, so you'll have to forgive me. I forgot to turn that off. And what I'm trying to do here is real quick, just do a follow-up on the, so this is really part 3. And just to show you that you can recycle your code, this was actually insert.scad, not collar.scad. I was actually going to make a collar to go over the outside so that you could just put a collar over the top of this without reprinting the whole thing. But you know what? Who cares? For the cost of the PLA, PLC, PLA, whatever it is, PLA. It's PLA. For the cost of the PLA, it's not worth buggerising around with it. So I'm just going to recycle what I've got. Don't need to change the inner diameter. the outer diameter goes to 57 and the width goes up to 67. Same number of spokes, but I've upped the thickness to 5. So let's make our STL file from that. I'm actually just going to save this design again, check the render, didn't change, make the STL file. It's actually insert, and I'm going to call it insert 2 so I can just recreate it. I don't want to lose the original design. So that's insert 2, ready to rock and roll. Now at the moment my printer's busy, you can hear it going in the background there. And it's printing this part out for my roller coaster. So I'm just going to leave that be for the moment, but I just wanted to show you guys, here's my nice collar. And when the part that's being printed finishes, I'm going to print this out. So let's leave that be for the moment and swap over to the other one when that's ready. Right, so what I've managed to do is overload my computer and cause all sorts of weird messages to be sent off to Mr. Microsoft. Okay, so we've got this thing. What we did was we compiled it here and we rendered it here and we created our STL file. Nothing to export. Oh, okay. When I went off to Mr. Microsoft, apparently I killed my compiler. So let's just recompile this polygon just to show you that we did do it. Here it comes. Hold your breath. Come on, come on, come on. Right, good, fantastic. Here it is. And there's our polygon. Compiled, rendered, STL file, and we actually called this insert 2. Alright, so we've already done that. I'm not going to go through that again, and I'm going to shut this software down. Why not? Let's save it. Right, so now we're going to open the Pt3 software. We are now finished with printing out our 3D. Wizzo. This was what we printed. Cool, huh? Somebody's saying, what the? And I'm actually saying, what the? Yep, pretty cool. It's all printed out. I'll have to get all the superfluous structure off that so people can see what it actually is. There's a lot of superfluous structure in this. But essentially what that is a loop-the-loop. Sits like this. And the ball bearing enters there, goes up there, over there, and out there. Cool. I'm going to put that in my bag of stuff to be done later. And we're going to get on with printing out our yoke. Right, so we want to connect back up to our printer. We're going to hit the manual control and just hit the home. There it goes. Everything's looking good there. It's going to take it a minute to do its thing. So the printer you can hear going in the background there, and we now have our total useless machine. We want to be here, and we have our insert number 2, which we're going to open. And here is our yoke. Whoa, this thing. Laugh at me if you will. But I'm telling you, that is our yoke. It stands 6.7 centimeters tall. And that is going to print out. So let's get into Slicer. I don't particularly want high quality. I'm just going to go with the default quality and slice it. Here it goes. Woofda, woofda, thank you, thank you. Getting there, Cure engine. You can see down here, generating, thank you, thank you. This is generating the G-code file which the printer can interpret. So it's converting it from an STL to a G-code file, if you're wondering what that's actually doing. And we can look at the G-code when it's finished. You can actually do that. So you can get in here, for example, and we can see the G-code. And it's a bunch of coordinate systems. And it has 34,000. 34,000. Let's try that again. 345,000 instructions that it's going to send to the printer. There it goes. And that file, generated with the Cure engine, blah, 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 home extruder, blah, 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 absolute positioning extruder, blah, 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 blah. So all that stuff there is about set everything up, go, blah, 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 type, skirt. So this is generating the skirt around the outside of the, at some point, I expect that's going to end. My goodness, that is going. And going and going and going and going. That makes very little sense. Okay, I saw G zeros. G1, G0, oh, who knows? That's G code. Looks wonderful, doesn't it? Makes no sense to anybody but the printer. Right. So let's forget that. Let's go here to our manual control. Let's go to our print preview. We've loaded that. We're happy with everything. That's what it's going to do. I'm going to close the G-code editor. I've seen enough G-code to last me a lifetime. Bit sick of seeing it. Righto, so here's our printer control. We're all set. We've done our slicer. We're in print preview, and we're going to hit, hold your breath, print. Now we're in our control screen. It's heating the bed up first. It's homing the printer. So we're over here. Now if I put this in the correct alignment, that's the alignment we're going to see at the printer. So if we're looking at the printer front on, this is what we will see happening on the surface of the printer. Okay. And the wires all the way at the very back. So at the moment, wires is pushed all the way to its outermost position. X is all the way over here on the left, Y is all the way down there. And that will move the bed and move the X as it moves. It's really cool. Yep, it's a bit like watching grass grow, because that'll get up to there, and then this one, when it turns on, we can intercede and turn it on, but we won't. So that's got to hit that dot, and then this one will climb until it hits that dot. So what we might do is pause this until such time that. Righto, so we're watching this hot end extruder nozzle here heat up. You can see it really cooks when it gets going. The bed temperature is at around 50 degrees Celsius, and this has to get up to around 210 degrees Celsius. And then you'll hear the printer take off. Now I'm just going to wrap the computer around towards the printer. And hopefully you'll see it move once this reaches temperature. Here it goes. You can see the X. Here it is doing the circle. So it's actually printing the inner circle. Now this is going to be a useful bit of kit because it's going to fix up our feeder. Right, we're going to put it in the inside of our new feeders. And we just hope to God that we've made it right. And the reason we hope to God we've made it right is this is going to take 2 hours and 58 minutes, ETE, 2 hours and 58 minutes. And it changes to an ETA. How cool is that? You can see it working up there in the corner. It's like watching grass grow. You can see that the system's going backwards and forwards and the bed's sliding backwards and forwards and the arms moving across and across. This is how the Prusa works. Rightio, so back to me. Anyone that doesn't believe that's the greatest rock band ever invented, right? Anyone that doesn't believe that, I refer you to the internet, sir. Like, ma'am, madam, sir, whoever you happen to be. Greatest rock band ever, AC/DC. Angus. Righto, so this is what's going on the printer. And that will take about 2 hours. I expect to have that in nearly 3 hours. Almost 3 hours left to print. Righto, so we're going to stop this. We might take some shots of it printing as it goes. But we're done. We're finished. And I'll see you guys at the end of all the printing. Right, so that 3D printing went on for about 2.5, nearly 3 hours. I should have been a little more prepared, but I wasn't. Sorry. I'll fix that later. Righto, so what we've ended up with is this. Our 3D printed thing, as you can see. It's thicker. Gee, there's a lot of sunlight there. It's got a thicker support. Wider, thicker. And that's the final product. It took, as I said, nearly 3 hours to print it out. And that's it. And it fits into the yoke of the bizzo. So let's get it over here so you can see it. Here it is. And it's a good fit. You push it in. And it does exactly the job it was designed to do. Fits in beautifully. And away we go into 3D printing land. So that's it. That's a wrap for this. If I can get that to go back where it belongs. There it is, back in its holder. The other one went somewhere, parts unknown, scuttled away under a bench or something. Find it later. But there it is. That was the end of the session. So just to wrap this up, what I've shown you is how to recycle modular code, how it works. We designed a modular system. We changed a couple of properties of the piece. We sent it off to the printer and the printer came back with exactly what we wanted. And it's doing its job. And that's a great example of a modular design where you can recycle the work you've done in the past, which is why I advocate object-oriented design in my videos. And if you get into the habit of doing that, you'll be able to recycle your code in all sorts of things, and you can take it into your professional life. I've done it for the better part of 30 years. I'm still using code that I developed 30 years ago, and if it ain't broke, don't fix it is basically one of the good axioms. And I've got a lot of code that ain't broke. Oh, excuse me. Righto, so I want you to make good decisions, do good things, keep on swinging at your goals. If you've got a choice, make the good choice, and get out there in the community, give back when you can. And I'll see you guys at the next video. Cheers.